Hello everyone, myself Kunjal Mehta from LJ Institute of Engineering and Technology, Ahmedabad. Today I am going to explain the topic Varistor Solar Cell and Dot Matrix Display of Basic Electronics subject. The chapter of Basic Electronics name is Special Purpose Diode. So let us start with the main component, that is varistor. The first component that we will study, varistors. Actually, dear students, the varistor is nothing but the voltage dependent resistor. So the definition of the varistor can be written like that. Voltage dependent resistor, which is the non-linear resistance, or the resistance of which changes in non-linear manner with respect to voltage applied across it. Thus, the voltage dependent resistor is called varistor. So that is nothing but the variable resistor, right? The varistor is a special device which is used for line filtering, avoid the spikes. So the next question is that, okay, why it is the special component? The varistor is a special device because it is used for what application? That's the line filtering. Okay, fine. To avoid the spikes and transients and noise like that. Okay. So it is also called the transient suppressor because it suppresses some transients and spikes and it filters out some unnecessary spikes. So due to its frequent use for protecting AC line from transients, that is the one of the application of varistor. So now, what is the main basic fundamental of varistor component or device? Varistor is a voltage dependent resistor, that is nothing but the non-linear resistor component which depends on only the voltage applied across it. And the varistor is the special device which is used to filter out and cuts off the noise or spikes and to avoid the transient, right? And therefore it is widely used in protecting purpose for protecting AC line from transients. Now the next important part of this varistor is the material and symbol. Okay, so the material of VDR is metal oxide, so it is also known as metal oxide varistor. Most commonly used material of MOV are ZNO or SiC. Now come to the point, varistor symbol. The symbol of varistor, which is similar to the back-to-back connected Zener diodes. Look at this. Dear students, these are the symbols of the varistor. Two symbols. It can be also drawn like this and it can be also drawn symbolically like this. But the main point is that it looks like the two back-to-back connected Zener diodes. In both the directions, its breakdown voltage is very high, which ranges from 10 volt to 1000 volt. The peak transient current capacity of varistor is hundreds or thousands of amperes. This is also most widely used the symbol. So dear students, remember this symbol for any of the circuit. Okay, now onwards. So this is the symbol of varistor. Now let's continue with the VI characteristic. Voltage current characteristic of the varistor. The characteristic is always drawn in four quadrant for VI characteristic of any of the diode. For example, PN junction diode, Zener diode, tunnel diode. So first we will have to draw the four quadrants. 1, 2, 3, 4. Forward region is drawn in the first quadrant and reverse region is drawn in the third quadrant. So as per the symbol and application, the working of varistor will look like this. Non-linear VI characteristic. Initially it will zero the current will zero up to some particular voltage, and after some particular varistor voltage, look at this is the varistor voltage. After some particular uh, voltage, the current increases sharply. Similarly, in reverse region, it breaks down after some particular reverse voltage. So it is shown in non-linear manner in first quadrant and in third quadrant. Okay, fine. This is the non-linear characteristic which is shown by the red color. And this black dotted line, that is the linear IV curve of fixed resistor. So students, you can also understand, I want to explain that main difference between the fixed resistor and variable resistor. So what is the varistor? It is the variable resistor, and it will have this non-linear characteristic which is shown by the red color. Okay, and in forward region and in reverse region, the straight cross line existence is known as linear current versus voltage characteristic curve of fixed resistor. Okay, so this is the difference between varistor and fixed resistor. Varistor is variable resistor, and this is the straight line curve, linear curve. It is a fixed resistor. So it can be easily concluded from the characteristic. Varistor application. Now we will continue with the main portion of this varistor, that is the application. In previous thing is also we have discussed about that the main application is of varistor is to protect the circuit, right? So how it protects? Any of the circuit that you want to protect, just connect the varistor in parallel, okay, with that circuit. So look at this. This is an example of electrical circuit to be protected, and this is the varistor symbol, which is also denoted by MOV or varistor. It is also connected in parallel with the electrical circuit to be protected, and this is the AC supply or DC supply. Now, how it protects? The main applied voltage. This is the applied voltage, which is also known as the surge voltage, right? When surge voltage is below or equal to varistor voltage, then the varistor works as a capacitor. But when the surge voltage exceeds the varistor voltage, the impedance across varistor terminal decreases rapidly. So according to this, the next parallel circuit will be protected automatically from the excessive current. If its impedance will be decreased, the most of the excessive current and noise will be filtered out by this vertical component which is known as variable resistance, that means varistor. And so that the electrical circuit which is connected behind this MOV, variable resistance or varistor will be protected. Again, I am repeating the varistor application. Always connect the electrical circuit and varistor in parallel and apply the AC or DC voltage. If AC or DC voltage, then there is no problem. It will behave like a capacitor. If it is equal or applied voltage will be equal or less than the varistor voltage, it will behave like a capacitor. But when input voltage, applied voltage, the surge voltage, the spark of voltage exceeds the varistor voltage, the impedance across varistor terminal decreases rapidly, and so the excessive current will pass through this varistor and no noise will be allowed to damage this electrical circuit. Okay. So now let's continue with the next component and device, that's the solar cell. Okay, dear students, from the name it implies the cell. Okay, so the solar cell, it is nothing but the photovoltaic cell. It is one type of battery symbol you can show like this, plus and minus, the big terminal and small terminal, similar to the battery. It is also known as the photovoltaic cell, and it is based on the principle of photovoltaic effect. Solar cell device which converts the light energy into the electrical energy. This is the principle. Okay, what is the principle of solar cell? Which converts the light energy into the electrical energy. Okay, fine. So what is the construction of solar cell? See, look at this students. This is the construction of the solar cell. First of all, it is nothing but the simple p-n junction. See, this is the n-type layer, thin layer. This is p-type layer, thicker than n-type layer. N-type is very thin and p-type layer is wide. Okay, this is the depletion zone. There are two plates, metallic plates. This is the front electrical contact and this is the back electrical contact. These are the metallic plates. Okay, this is the load. Black is electron and red is shown denoted by Hall. So electron is indicated by black circle and Hall is indicated by red circle. The photon will be absorbed in depletion zone electron Hall pair creation. That is the main solar cell construction and working. Okay. So this is the yellow color photon will be focused and it will be absorbed by this construction and how the load will react. So it is our understanding and explanation, right? The surface layer n-type material should be extremely thin and so that light can easily reach to the junction. Okay, fine. That's why the n-type is very thin. This is the reason because the light can easily reach to the junction. The top layer can be p-type sometimes. You can also arrange p-n. Top layer is p and bottom layer is n. But n-type is more effective than p-type. That's why I have connected here. The n-type is in the top and very thin. Now solar cell working. The next point I want to explain that how it works on the basis of photovoltaic effect. Always we know that whenever the light focused on the p-n junction, it will be absorbed by the junction. Okay. So when n-type material is extremely thin, so light strikes on the cell and the photon light energy is absorbed by the semiconductor material in depletion region. So the number of electron hole pair will be generated. Thus, electron hole flow to continue the photocurrent. So it will constitute the photocurrent and this photocurrent produces a voltage across load resistance. Consider this is the load or also you can consider this is the bulb. If a photon will be absorbed by the p-n junction, electron hole pairs will be created and more electron hole pairs will be created, then electron flow will create. It will constitute the current and due to the constitution of the current, if load is bulb, then bulb will glow. So thus light energy will be converted into the electrical energy. Thus solar cell works. Okay. Let us discuss the next components in special purpose diode chapter, that is dot matrix LED display. Look at this. It is one type of matrix, right? One type of matrix and these are the columns. You can just um, assume these are the columns. How many columns? 1, 2, 3, 4, 5. And you can visualize this. These are the rows. 1, 2, 3, 4, 5, 6, 7. Okay. So, 5 columns and 7 rows, different patterns can be generated of the LEDs. All LEDs are connected in some particular such pattern and using dot connection. That's why the name of this construction is dot matrix LED display. We are using the main component that is LED and the arrangement of LEDs will be the connection of columns and rows. So different types of pattern can be used. Okay, so different types of dot matrix displays, patterns and matrices or types, whatever you say, it will be 5 cross 7, 5 cross 8, 7 cross 9. Out of this, three patterns, 5 cross 7 is most widely used. So I have also shown you this 5 cross 7, 5 columns and 7 rows of LEDs. So this type of patterns are used to for LED display. Okay, to connect the LEDs in different type of manners and patterns. A dot matrix controller converts the instruction from processor into the signals. So this is the working. Actually, the main thing is that what is the construction, which component is used, how it is connected, and next you will think about what is the working of this component and device, right? So what will be the working of dot matrix LED display? Different types of the column cross rows, 5 cross 7 wiring pattern will be used to convert the instruction from processor into the signals. And particular LEDs will be on and off. So according to the connection, according to the getting signals from the microprocessor and controller, few LEDs will be on and few LEDs will be off. So according to turn on and turn off the LEDs of display, so that required pattern will be produced. And real-time applications, we are using dot matrix LED very nicely in machines, clocks, railway and airplane information displays, watches and calculators applications. Okay, so dot matrix LED display will be useful in real-time application in most of the machines and for display purpose. Okay, fine. Again, I am repeating the main points of today's lecture. Today we have studied about the main topic and we have discussed about the special purpose diode chapter, in which we have studied the three main components. Those are varistor, which is voltage dependent resistor, which is used for the protection purpose of any of the electrical circuit, which will be connected in parallel. So excessive noise can be filtered out. Then we have studied and I have discussed and I have explained in detail the construction of the solar cell and working of the solar cell, which is based on the photovoltaic effect, in which the light energy is converted into the current or electrical energy, right? And in lastly, we have studied the dot matrix LED display, which has some particular pattern to on off to produce some particular pattern display, right, as per the requirement. So in very many of the real-time applications, we are using the dot matrix display. Okay, so dear students, if you have any doubt, you can ask me anytime. Thank you.